Hello, students. Today, we are going to explore the fascinating properties of ionic compounds in detail. Have you ever wondered what gives table salt its perfect crystal shape, or why it dissolves so easily in water? We're going to find out.
So let's quickly look at our plan for today's lesson so you know exactly what we will be covering. We'll start with a recap of ionic bonds. Then, we will look at 4 key properties: their physical nature, their high melting points, their solubility, and finally, their electrical conductivity.
All right, before we can discuss the properties, it's very important that we quickly recall how an ionic bond is formed in the first place.
Remember, an ionic bond is all about the complete transfer of one or more electrons, usually from a metal to a nonmetal. This creates that strong electrostatic force of attraction between the positive ion and the negative ion.
A perfect example is sodium chloride. The sodium atom gives away an electron, becoming a positive ion. The chlorine atom takes that electron, becoming a negative ion. This give and take relationship creates a very, very strong attraction, and this attraction is the key to understanding all the properties we are going to discuss next.
Okay, so let's dive into our first property. What do these compounds actually look and feel like?
Well, think of a crystal of common salt. It is hard, isn't it? But if you take that salt crystal and apply pressure, maybe with a hammer, it shatters into pieces. This is because of the strong forces holding the ions. When you apply pressure, the layers of ions shift. Suddenly, positive ions are next to other positive ions and they repel each other, causing the crystal to break. So they are hard, but also brittle.
Now let's see what happens when we try to heat these compounds.
As you can see from this table, which is from your textbook, ionic compounds have very high melting and boiling points. Just look at the numbers for sodium chloride, 1074 Kelvin for the melting point. That's very, very hot.
I want you to pause and think for a moment. What is holding the solid together that requires so much energy to break it?
That's right. It all comes back to that strong attraction. The positive and negative ions are held together so tightly in the crystal structure that you need a large amount of heat energy to make them move apart and turn into a liquid.
Okay, let's move on to our next property and see what happens when we try to dissolve them.
So, ionic compounds, like salt, they usually dissolve in water. But they do not dissolve in solvents like kerosene or petrol. Why is this? It's because water molecules are special. They are polar. This means they can surround and stabilize the individual ions, breaking them apart from the crystal. Kerosene and petrol can't do this, so the crystal just stays together.
Now for a very important property, especially for your exams. How do these compounds conduct electricity?
Well, the answer's interesting. It's not a simple yes or no. It depends entirely on the state of the compound.
Now, remember, to conduct electricity, you need charged particles that must be free to move. So let's imagine a circuit with a battery and a bulb. We place 2 electrodes into a sample of our ionic compound, and we see if the bulb glows.
Okay, so here are the results. In the solid state, the ions are locked in that rigid structure. They cannot move, so the bulb does not glow. But when we melt the compound, the ions become free to move, so the bulb glows. And what about when we dissolve it in water? Again, the ions separate and are free to move. And yes, the bulb glows. So, the crucial point here is that ionic compounds only conduct electricity when their ions are free to move, which happens in the molten state or in a water solution.
And please, note this carefully. This is a very common point of confusion in exams. In a metallic wire, electricity is conducted by free electrons. But in an ionic solution, the charge is carried by the movement of ions.
All right, let's quickly summarize what we have learned today.
I want you to remember these 4 key properties and the reasons behind them. They are hard but brittle solids. They have very high melting and boiling points. They are soluble in water, and they conduct electricity only in their molten or aqueous states. And remember, all of this connects back to that strong bond between the ions.
So, this brings us to our next important topic. We've seen how strong these compounds are, but many metals are found locked inside them in the Earth's crust. So how do we get them out? This is the study of metallurgy, and we will study the extraction of metals in our next lesson.